right, lesson 2 of unit 9. Let's dive right in. We're going to talk about prime factorization. This very well might be a totally brand new concept for you, but it's not going to be that difficult, I don't believe. So let's see what we can do. All right, so first of all, let's talk about prime numbers versus composite numbers. Now, this might not be new. This part might be review. So what is a prime number? A prime number is something like 17. 17 is a number that can only be factored. That word is going to be important in a minute, right? This is kind of the title of the lesson. Into itself in 1. So 1 times 17. So its only factors are 1 and 17. So the only things that can multiply to get 17 are 1 and 17, right? There aren't any others. Unlike a composite number like, say, 15. 15 it does have the 1 and 15, right? 1 times 15 gives us 15, right? But we can also split it into like 3 times 5 as well. So composite numbers are numbers that can be split, that more than just 1 and the number can multiply to get the number. So that's the difference between prime and composite numbers. Now, what is prime factorization? I think it's going to be easiest to explain what it is by doing an example. So let's jump in and do that. So the first example is, what is the prime factorization of 90? So what factoring is it's taking something that is a sum and turning it into products, into the smallest possible products. I'll show you what it means. And I say that more kind of for future idea, right? Because we're going to have things that are binomials and polynomials and trinomials and all these other things that we're going to factor, and it's going to have lots of letters. We're going to do an example with letters in it, but it's going to be a pretty easy example. But let's start with this one, 90. So to do prime factorization of 90, what we do, and the way we do that is we do what's called a factor tree. So we start by thinking, okay, what are two things that multiply to get to 90? Well, first couple could be pretty easy, right? Because it's got a 0 at the end, so 10 goes into 90. So we can definitely split this into 9 and 10, because 9 times 10 gives us 90. If you want to put little times symbols in between the numbers as we go down the tree, you can. You don't have to, but you certainly can, right? So now we got it. This is where it becomes a factor tree, right? Is where we look at this and say, okay, what things are there? Anything that multiplied to get 9 and anything multiplied to get 10? So let's look specifically at 9. So is 9 prime or not? No, because we can split this into 3 times 3. 3 times 3 gives us 9. So 10, is 10 prime? No, it's not, because we can do 5 and 2. 5 times 2. Now, these numbers down at the bottom, these are all prime numbers. 3, 5, and 2 are all prime, because they can only be factored into themselves in 1. Only 1 times the number gives us that number. So the prime factorization, well, now that we've gotten it all the way down to prime numbers, would be 3 times 3 times 5 times, oops, that turned out like crazy. What happened to that 5? He just thought he should be extra today. Let's fix it. There we go. Okay, so 3 times 3 times 5 times 2. So we list out all the prime factors. And if you go and take your calculator now and you did 3 times 3 times 5 times 2, guess what you'd get? You'd get 90. So that's what prime factorization of a number looks like. We're splitting it into all the factors that give us 90, or whatever number it is, right? So let's do one other example with letters in it. Sounds scary, but actually it's almost easier. So we're going to start out by factoring this example right here, right? This one, I'm going to move it over so I have a little bit more room to kind of factor tree it up, right? So first of all, we look at the number. So can we split 11 into factors, or is it prime? Well, 11 is prime, right? Nothing goes into 11, right? Nothing does. And so we're not going to do anything with the number. But with the letters, so how do we do the letters? Well, the letters are actually even easier. How many R's? What does this mean? We learned about exponents in the last lesson, right? So R to the fourth would be R times R times R times R, and so that's the prime factorization there. So 11 times R times R times R times R, and then we've just got one S, so times S, and that's the prime factorization of that monomial. Right now, this one, the 28. So I'm going to go ahead and do a factor tree to figure out all the factors of 28. Right. So let's start with that. I'm going to do it in different colors so it's real clear over here. So 28. Now, what is going to happen with negative? It's if you're already asking that, well, it's just going to come down later. So don't stress about it, but also don't forget about it later. So you might be like, okay, what goes into 28? There's several different options, right? So pick the one that jumps out to you. So you might be like, well, it's even. So 2 times what equals 28? Well, 2 times 14 equals 28. So 2 is prime, so he's done. Now, some teachers will teach, and this can be a great idea to kind of go, and once you get down to a prime, to circle that number or underline it or something so that you know, okay, I'm done with that branch. I can move on. I can fix all the rest of the branches. If you want to do that, you certainly can. So you can look at 14, and again, you think, okay, it's even. So what 2 and something, right? 2 times 7 gives us 14, and 2 and 7 are both prime, right? So let's start writing our answers. A negative. Now you notice I'm going to list all the ones at the bottom of the tree, even though this one's in that 90 example, we had this kind of even bottom, right? They were all on the bottom. There wasn't some up here like this one is. Well, in this one, the 2 is up here, but it's still one of the prime factors. If it's down at the bottom and doesn't have anything branching off of it, then it's one of the factors. So in this example, we've got the prime factors of negative 2 times 2 times 7. Now, you notice the negative just kind of floated on down to the bottom, right? We didn't worry about it. And then for the letters, we've got times A, and there's 3 B's, so times B, times B, times B. That's really easy stuff, y'all. And that is all there is to that lesson. No big deal at all. If you're in my class, I'll see you in class. If you're not in my class, thanks for joining us in this video. Hope it was helpful to you. See you in the next one. Bye-bye, everyone.